The Magic of Reality: How We Know What's Really True by Richard Dawkins, best-selling author of The Selfish Gene. Illustrated by Dave McKean.
Chapter 9. Are We Alone? So far as I know, there are few, if any, ancient myths about alien life elsewhere in the universe. Perhaps because the very idea of there being a universe vastly bigger than our own world hasn't been around all that long. It took until the 1500s for scientists to see clearly that the Earth orbits the Sun, and that there are other planets that do so too. But the distance and number of the stars, let alone other galaxies, was unknown and undreamed of until relatively modern times. And it isn't that long since people first realized that the direction we call straight up in one part of the world, for example Borneo, would be straight down in another part of the world, in this case, Brazil. Before then, people thought that up was the same direction everywhere, towards the place where the gods lived, above the sky. There have long been numerous legends and beliefs about strange alien creatures near at hand. Demons, spirits, jinns, ghosts, the list goes on. But in this chapter, when I ask, are we alone? I am going to mean, are there alien life forms on other worlds elsewhere in the universe? As I said, myths about aliens in this sense are rare among primitive tribes. They are all too common, however, among modern city dwellers. These modern myths are interesting because unlike ancient myths, we can actually watch as they start. We see myths being dreamed up before our very eyes. So the myths in this chapter will be modern. In California, in March 1997, a religious cult called Heaven's Gate came to a sad end when all 39 of its members took poison. They killed themselves because they believed that a UFO from outer space would take their souls to another world. At the time, a bright comet called Hale-Bopp was prominent in the sky, and the cult believed, because their spiritual leader told them so, that an alien spacecraft was accompanying the comet on its journey. They bought a telescope to observe it, but then sent it back to the shop because it didn't work. How did they know it didn't work? Because they couldn't see the spacecraft through it. Did the cult leader, a man called Marshall Applewhite, believe the nonsense he taught his followers? Probably he did, because he was one of those who took the poison, so it looks as though he was sincere. Many cult leaders are in the business only so they can take possession of their female followers, but Marshall Applewhite was one of several cult members who had earlier had themselves castrated, so perhaps sex was not uppermost in his mind. One thing most such people seem to have in common is a love of science fiction. The members of the Heaven's Gate cult were obsessed with Star Trek. Of course, there is no shortage of science fiction stories about aliens from other planets, but most of us know that's just what they are. Fiction, imagined, invented stories, not accounts of things that actually happened. But there are quite a lot of people who firmly, sincerely, and unshakably believe that they have personally been captured, abducted by aliens from outer space. So eager are they to believe this that they will do so on the flimsiest of evidence. One man, for instance, believed he had been abducted for no better reason than that he often got nosebleeds. His theory was that the aliens had put a radio transmitter in his nose to spy on him. He also thought he might be part alien himself, on the grounds that his coloring was a little darker than his parents'. A surprisingly large number of Americans, many of them otherwise normal, sincerely believe that they personally have been taken aboard flying saucers and been the victims of horrific experiments conducted by little gray men with large heads and huge wraparound eyes. There is a whole mythology of alien abductions, which is as rich, as colorful, and as detailed as the mythology of ancient Greece and the gods of Mount Olympus. But these alien abduction myths are recent, and you can actually go and talk to people who believe they have been abducted, apparently normal, sane, level-headed people who will tell you they saw the aliens face to face, actually tell you what the aliens look like and what they saw while performing their nasty experiments and sticking needles into people. The aliens speak English, of course. Susan Clancy is one of several psychologists who have made detailed studies of people who claim to have been abducted. Not all of them have clear memories of the event or even any memories at all. They account for this by saying that obviously the aliens must have used some devilish technique to wipe their memories clean after they had finished experimenting on their bodies. Sometimes they go to a hypnotist or a psychotherapist of some kind who helps them to recover their lost memories. Recovering lost memory is a whole other story, by the way, which is interesting in its own right. When we think we remember a real incident, we may only be remembering another memory, and so on back to what may or may not have been a real incident originally. Memories of memories of memories can become progressively distorted. There is good evidence that some of our most vivid memories are actually false memories, and false memories can be deliberately planted by unscrupulous therapists. False memory syndrome helps us understand why at least some of the people who think they have been abducted by aliens claim to have such vivid memories of the incident. What usually happens is that a person becomes obsessed with aliens through reading stories in the newspapers about other alleged abductions. Often, as I said, these people are fans of Star Trek or other science fiction tales. It is a striking fact that the aliens they think they've met usually look very like the ones portrayed in the most recent television fiction about aliens, and they usually do the same kind of experiments as have recently been seen on television. The next thing that may happen is that the person is afflicted by a frightening experience called sleep paralysis. It is not uncommon. You may even have experienced it yourself, in which case I hope it will be a bit less scary the next time it happens if I explain it to you now. Normally, when you are asleep and dreaming, your body is paralyzed. I suppose it's to stop your muscles working in tune with your dreams and making you sleepwalk, though this does, of course, sometimes happen. And normally, when you wake and your dream vanishes, the paralysis goes and you can move your muscles. But occasionally, there is a delay between your mind returning to consciousness and your muscles coming back to life, and that is called sleep paralysis. It is frightening, as you can imagine. You are sort of awake, and you can see your bedroom and everything in it, but you can't move. Sleep paralysis is often accompanied by terrifying hallucinations. People feel surrounded by a sense of dreadful danger, which they can't put a name to. Sometimes they even see things that are not there, just as in a dream. And, also as in a dream, to the dreamer, they seem absolutely real. Now, if you are going to have a hallucination when you suffer sleep paralysis, what might that hallucination look like? A modern science fiction fan might well see little gray men with big heads and wraparound eyes. In earlier centuries, before science fiction came along, the visions people saw were different. Hobgoblins, perhaps, or werewolves, blood-sucking vampires, or, if they were lucky, beautiful winged angels. The point is that the images people see when experiencing sleep paralysis are not really there, but are conjured up in the mind from past fears, legends, or fiction. Even if they don't hallucinate, the experience is so frightening that when they finally wake up, sleep paralysis victims often believe that something horrible has happened to them. If you are primed to believe in vampires, you might wake with a strong belief that a bloodsucker has attacked you. If I am primed to believe in alien abductions, I might wake up believing that I was abducted and my memory then wiped clean by aliens. The next thing that typically happens to sleep paralysis victims is that even if they didn't actually hallucinate aliens and gruesome experiments at the time, their fearful reconstruction of what they suspect may have happened becomes consolidated as a false memory. This process is often helped along by friends and family who eagerly pump them for more and more detailed accounts of what happened, and even prompt them with leading questions. Were there aliens there? What color were they? Were they gray? Did they have big wraparound eyes like in the movies? Even questions can be enough to implant or cement a false memory. When you look at it like this, it is not so surprising that a 1992 poll concluded that nearly 4 million Americans thought they had been abducted by aliens. My friend, the psychologist Sue Blackmore, points out that sleep paralysis was the most likely cause of earlier imagined horrors too, before the idea of space aliens became popular. In medieval times, people claimed to have been visited in the middle of the night by an incubus, a male demon visiting a female victim to have sex with her, or succubus, a female demon visiting a male victim to have sex with him. One of the effects of sleep paralysis is that if you try to move, it feels as though something is pressing down on your body. This could easily be interpreted by the terrified victim as a sexual assault. Legend in Newfoundland talks of an old hag who visits people in the night and presses down on their chests. And there is a legend in Indochina of a gray ghost who visits people in the dark and paralyzes them. So we have a good understanding of why people believe they have been abducted by aliens, and we can tie the modern myths of alien abduction in with earlier myths of rapacious incubi and succubi, or of vampires with long canine teeth who visit in the night and suck our blood. There is no good evidence at all that this planet has ever been visited by aliens from outer space, or, for that matter, by incubi or succubi or demons of any kind. But we are still left with the question of whether there actually are living things on other planets. Just because they haven't visited us, it doesn't mean they don't exist. Could the same process of evolution, or even a very different process that perhaps resembles our kind of evolution only slightly, have not going on other planets as well as ours? Is there really life on other planets? Nobody knows. If you forced me to give an opinion one way or the other, I'd say yes, and probably on millions of planets. But who cares about an opinion? There is no direct evidence. One of the great virtues of science is that scientists know when they don't know the answer to something. They cheerfully admit that they don't know. Cheerfully, because not knowing the answer is an exciting challenge to try to find it. One day, we may have definite evidence of life on other planets, and then we'll know for sure. For now, the best a scientist can do is write down the kind of information that might reduce the uncertainty, might take us from guesswork to an estimate of likelihood. And that, in itself, is an interesting and challenging thing to do. The first thing we might ask is how many planets there are. Until quite recently, it was possible to believe that the ones orbiting our sun were the only ones, because planets could not be detected by even the largest telescopes. Nowadays, we have good evidence that lots of stars have planets, and new extrasolar planets are discovered almost every day. An extrasolar planet is a planet orbiting a star other than the sun. Sol is the Latin for sun, and extra is the Latin for outside. You might think that the obvious way to detect a planet is to see it through a telescope. Unfortunately, planets are too dim to be seen at any great distance. They don't glow in their own right, but only reflect their star's light, so we can't see them directly. We have to rely on indirect methods, and the best method again makes use of the spectroscope, the instrument we met in Chapter 8. Here's how. When a heavenly body orbits another one of approximately equal size, they orbit each other because they exert approximately equal gravitational force on each other. Several of the bright stars that we see when we look up are actually two stars, so-called binaries, in orbit around each other like the two ends of a dumbbell connected by an invisible rod. When one body is much smaller than the other, as is the case with a planet and its star, the smaller one whizzes around the larger one, while the larger one makes only little token movements in response to the gravitational pull of the smaller. We say that Earth orbits the Sun, but actually the Sun also makes tiny movements in response to the gravity of Earth. And a planet as large as Jupiter can have an appreciable effect on the position of its star. These token movements of a star are too small to count as going round the planet, but they are large enough to be detected by our instruments, even though we can't see the planet at all. How we detect these movements is interesting in its own right. Any star is too far away for us to be able to see it actually moving, even with a powerful telescope. But, strangely, although we can't see a star move, we can measure the speed with which it does so. That sounds odd, but this is where the spectroscope comes in. Remember the Doppler shift from Chapter 8? When the star's movement happens to be away from us, the light from it will be red-shifted. When the star's movement is towards us, its light will be blue-shifted. So, if a star has an orbiting planet, the spectroscope will show us a rhythmically pulsating red-blue shift pattern, and the timing of these regular shifts will tell us the length of the planet's year. Of course, it's complicated when there's more than one planet, but astronomers are good at mathematics and they can cope with that complication. At the time of writing, January 2011, 484 planets have been detected by this means, orbiting 408 stars. There will surely be more by the time you read this. There are other methods of detecting planets. For example, when a planet passes across the face of its star, a small portion of the face of the star is obscured or eclipsed, like when we see the moon eclipsing the sun, except that the moon looks much bigger because it is so much closer. When a planet comes between us and its star, the star becomes very, very slightly dimmer, and sometimes our instruments are sensitive enough to detect this dimming. So far, 110 planets have been discovered in this way, and there are a few other methods too, which have detected another 35 planets. Some planets have been detected by more than one of these techniques, and the present grand total is 519 planets orbiting stars in our galaxy other than the Sun. In our galaxy, the great majority of stars where we have looked for planets have turned out to possess them. So, assuming our galaxy is typical, we can probably conclude that most of the stars in the universe have planets in orbit around them. The number of stars in our galaxy is about 100 billion, and the number of galaxies in the universe is about the same again. That means something like 10,000 billion stars in total. About 10% of known stars are described by astronomers as sun-like. Stars that are very different from the sun, even if they have planets, are unlikely to support life on those planets for various reasons. For example, stars that are much bigger than the sun tend not to last long enough before exploding. But even if we confine ourselves to the planets orbiting sun, like stars, we are likely to be dealing in billions of billions, and that would probably still be an underestimate. All right, but how many of those planets orbiting the right kind of star are likely to be suitable for supporting life? The majority of extrasolar planets discovered so far are Jupiters. That means they are gas giants, mostly made of gas at high pressure. This is not surprising, as our methods of detecting planets are usually not sensitive enough to notice anything smaller than Jupiters. And Jupiters, gas giants, are not suitable for life as we know it. Of course, that doesn't mean that life as we know it is the only possible kind of life. There might even be life on Jupiter itself, although I doubt it. We don't know what proportion of those billions of planets are Earth-like rocky planets as opposed to Jupiter-like gas giants. But even if the proportion is quite low, the absolute number will still be high because the total is so huge. Looking for Goldilocks. Life as we know it depends on water. Once again, we should beware of fixing our attention on life as we know it, but for the moment, exobiologists, scientists searching for extraterrestrial life, regard water as essential, so much so that a good part of their effort is given over to searching the heavens for signs of it. Water is a lot easier to detect than life itself. If we find water, it certainly doesn't mean there has to be life, but it is a step in the right direction. For life as we know it to exist, at least some of the water has to be in liquid form. Ice won't do, nor will steam. Close inspection of Mars shows evidence of liquid water in the past, if not today. And several other planets have at least some water, even if it is not in liquid form. Europa, one of the moons of Jupiter, is covered with ice, and it has been plausibly suggested that under the ice is a sea of liquid water. People once thought Mars was the best candidate for extraterrestrial life within the solar system, and a famous astronomer called Percival Lowell even drew what he claimed were canals crisscrossing its surface. Spacecraft have now taken detailed photographs of Mars and have even landed on its surface, and the canals have turned out to be figments of Lowell's imagination. Nowadays, Europa has taken the place of Mars as the prime site of speculation about extraterrestrial life in our own solar system, but most scientists think we have to look further afield. Evidence suggests that water is not particularly rare on extrasolar planets. What about temperature? How finely tuned does the temperature of a planet have to be if it is to support life? Scientists talk of a so-called Goldilocks zone, just right, like baby bear's porridge, between two wrong extremes of too hot, like father bear's porridge, and too cold, like mother bear's porridge. The orbit of Earth is just right for life, not too close to the sun where water would boil, and not too far from the sun where all the water would freeze solid and there wouldn't be enough sunlight to feed the plants. Although there are billions and billions of planets out there, we cannot expect more than a minority of them to be just right where temperature and distance from their star are concerned. Recently, May 2011, a Goldilocks planet was discovered orbiting a star called Gliese 581, which is about 20 light years away from us, not very far as stars go, but still a vast distance by human standards. The star is a red dwarf, much smaller than the Sun, and its Goldilocks zone is correspondingly closer in. It has at least 6 planets named Gliese 581e, b, c, g, d, and f. Several of them are small, rocky planets like Earth, and one of them, Gliese 581d, is thought to be in the Goldilocks zone for liquid water. It is not known whether Gliese 581d actually has water, but if so, it is likely to be liquid rather than ice or vapor. Nobody is suggesting that Gliese 581d actually does have life, but the fact that it has been discovered so soon after we started looking makes one think there are probably lots of Goldilocks planets out there. What about the size of a planet? Is there a Goldilocks size, not too big and not too small, but just right? The size of a planet, more strictly its mass, has a big impact upon life because of gravity. A planet with the same diameter as Earth, but mostly made of solid gold, would have a mass more than 3 times as great. The gravitational pull of the planet would be over 3 times as strong as we are used to on Earth. Everything would weigh more than 3 times as much, and that includes any living bodies on the planet. Putting one foot in front of the other would be a great labor. An animal the size of a mouse would need to have thick bones to support its body, and it would lumber about like a miniature rhinoceros, while an animal the size of a rhinoceros might suffocate under its own weight. Just as gold is heavier than the iron, nickel, and other things that Earth is mostly made of, coal is much lighter. A planet the size of Earth, but mostly made of coal, would have a gravitational pull only about a fifth as strong as we are used to. An animal the size of a rhinoceros could skitter about on thin, spindly legs like a spider, and animals far bigger than the largest dinosaurs could happily evolve if the other conditions on the planet were right. The moon's gravity is about 1/6 that of Earth. That is why astronauts on the moon moved with a curious bounding gait, which looked quite comical because of their large bulk in their spacesuits. An animal that actually evolved on a planet with such weak gravity would be built very differently. Natural selection would see to that. If the gravitational pull were too strong, as it would be on a neutron star, there could be no life at all. A neutron star is a kind of collapsed star. As we learned in Chapter 4, matter normally consists almost entirely of empty space. The distance between atomic nuclei is vast, compared with the size of the nuclei themselves. But in a neutron star, the collapsing means that all that empty space has gone. A neutron star can have as much mass as the Sun, yet be only the size of a city, so its gravitational pull is shatteringly strong. If you were plonked down on a neutron star, you would weigh 100 billion times what you weigh on Earth. You'd be flattened. You couldn't move. A planet would only need to have a tiny fraction of the gravitational pull of a neutron star to put it outside the Goldilocks zone, not just for life as we know it, but for life as we could possibly imagine it. Here's looking at you. If there are living creatures on other planets, what might they look like? There's a widespread feeling that it's a bit lazy for science fiction authors to make them look like humans with just a few things changed, bigger heads or extra eyes or maybe wings. Even when they are not humanoid, most fictional aliens are pretty clearly just modified versions of familiar creatures, such as spiders, octopuses, or mushrooms. But perhaps it is not just lazy, not just a lack of imagination. Perhaps there really is good reason to suppose that aliens, if there are any, and I think there probably are, might not look too unfamiliar to us. Fictional aliens are proverbially described as bug-eyed monsters, so I'll take eyes as my example. I could have taken legs or wings or ears, or even wondered why animals don't have wheels. But I'll stick to eyes and try to show that it isn't really lazy to think that aliens, if there are any, might very well have eyes. Eyes are pretty good things to have, and that is going to be true on most planets. Light travels, for practical purposes, in straight lines, wherever light is available, such as in the vicinity of a star. It is technically easy to use light rays to find your way around, to navigate, to locate objects. Any planet that has life is pretty much bound to be in the vicinity of a star, because a star is the obvious source of the energy that all life needs. So the chances are good that light will be available wherever life is present, and where light is present, it is very likely that eyes will evolve because they are so useful. It is no surprise that eyes have evolved on our planet dozens of times independently. There are only so many ways to make an eye, and I think every one of them has evolved somewhere in our animal kingdom. There's the camera eye, above left, which, like the camera itself, is a darkened chamber with a small hole at the front letting in light through a lens, which focuses an upside-down image on a screen, the retina, at the back. Even a lens is not essential. A simple hole will do the job if it is small enough, but that means that very little light gets through, so the image is very dim. Unless the planet happens to get a lot more light from its star than we get from the sun. This is, of course, possible, in which case the aliens could indeed have pinhole eyes. Human eyes, opposite, right, have a lens to increase the amount of light that is focused in the retina. The retina at the back is carpeted with cells that are sensitive to light and tell the brain about it via nerves. All vertebrates have this kind of eye, and the camera eye has been independently evolved by lots of other kinds of animals, including octopuses, and invented by human designers too, of course. Jumping spiders, left below, have a weird kind of scanning eye. It is sort of like a camera eye, except that the retina, instead of being a broad carpet of light-sensitive cells, is a narrow strip. The strip retina is attached to muscles which move it about so that it scans the scene in front of the spider. Interestingly, that is a bit like what a television camera does too, since it has only a single channel to send a whole image along. It scans across and down in lines, but does it so fast that the picture we receive looks like a single image. Jumping spider eyes don't scan so fast, and they tend to concentrate on interesting parts of the scene, such as flies, but the principle is the same. Then there's the compound eye, right below, which is found in insects, shrimps, and various other animal groups. A compound eye consists of hundreds of tubes radiating out from the center of a hemisphere, each tube looking in a slightly different direction. Each tube is capped by a little lens, so you could think of it as a miniature eye. But the lens doesn't form a usable image. It just concentrates the light in the tube. Since each tube accepts light from a different direction, the brain can combine the information from them all to reconstruct an image, rather a crude image, but good enough to let dragonflies, for instance, catch moving prey on the wing. Our largest telescopes use a curved mirror rather than a lens. And this principle too is used in animal eyes, specifically in scallops. The scallop eye uses a curved mirror to focus an image on a retina, which is in front of the mirror. This inevitably gets in the way of some of the light, as the equivalent does in reflecting telescopes, but it doesn't matter too much as most of the light gets through to the mirror. That list pretty much exhausts the ways of making an eye that scientists can imagine, and all of them have evolved in animals on this planet, most of them more than once. It is a good bet that, if there are creatures on other planets that can see, they will be using eyes of a kind that we would find familiar. Let's exercise our imaginations a bit more. On the planet of our hypothetical aliens, the radiant energy from their star will probably range from radio waves at the long end to X-rays at the short. Why should the aliens limit themselves to the narrow band of frequencies that we call light? Maybe they have radio eyes or X-ray eyes. A good image relies on high resolution. What does that mean? The higher the resolution, the closer 2 points can be to each other while still being distinguished from each other. Not surprisingly, long wavelengths don't make for good resolution. Light wavelengths are measured in minute fractions of a millimeter and give excellent resolution, but radio wavelengths are measured in meters. So radio waves would be lousy for forming images, although they are very good for communication purposes because they can be modulated. Modulated means changed extremely rapidly in a controlled way. So far as is known, no living creature on our planet has evolved a natural system for transmitting, modulating, or receiving radio waves. That had to wait for human technology. But perhaps there are aliens on other planets that have evolved radio communication naturally. What about waves shorter than light waves, X-rays for example? X-rays are difficult to focus, which is why our X-ray machines form shadows rather than true images. But it is not impossible that some life forms on other planets have X-ray vision. Vision of any kind depends on rays traveling in straight or at least predictable lines. It is no good if they are scattered every which way, as light rays are in fog. A planet that is permanently shrouded in thick fog would not encourage the evolution of eyes. Instead, it might foster the use of some kind of echo-ranging system like the sonar used in bats, dolphins, and man-made submarines. River dolphins are extremely good at using sonar because their water is full of dirt, which is the watery equivalent of fog. Sonar has evolved at least 4 times in animals on our planet, in bats, whales, and 2 separate kinds of cave-dwelling birds. It would not be surprising to find sonar evolving on an alien planet, especially one that is permanently shrouded in fog. Or, if the aliens have evolved organs that can handle radio waves for communication, they might also evolve true radar to find their way around, and radar does work in fog. On our planet, there are fish that have evolved the ability to find their way about using distortions in an electric field that they themselves create. In fact, this trick has evolved twice independently, in a group of African fish and in a completely separate group of South American fish. Duck-billed platypuses have electric sensors in their bills which pick up the electrical disturbances in water caused by the muscular activity of their prey. It is easy to imagine an alien life form that has evolved electrical sensitivity along the same lines as the fishes and the platypus, but to a more advanced level. This chapter is rather different from the others in this book because it emphasizes what we don't know rather than what we do. Yet, even though we have not yet discovered life on other planets, and indeed may never do so, I hope you have seen and been inspired by how much science can tell us about the universe. Our search for life elsewhere is not haphazard or random. Our knowledge of physics and chemistry and biology equips us to seek out meaningful information about stars and planets vast distances away, and to identify planets that are at least possible candidates as hosts for life. There is much that remains deeply mysterious, and it is not likely that we will ever uncover all the secrets of a universe as vast as ours. But, armed with science, we can at least ask sensible, meaningful questions about it and recognize credible answers when we find them. We don't have to invent wildly implausible stories. We have the joy and excitement of real scientific investigation and discovery to keep our imaginations in line. And in the end, That is more exciting than fantasy.